All right, so 12-2 chords and arcs. So I'm not going to be in class today, so here's what you need to know. Here's what we got. So congruent central angles have congruent chords. Chords are the straight lines. So if we're looking at this one right here, here is your central angle from here to here. These are central angles. Since these two angles are congruent, we can say this chord and this chord are congruent. So how would you write that? You would say like segment AB is congruent to segment CD, right? All right, so those two are congruent. And that only works if these two angles are congruent. We can actually go backwards. Let's say these two are congruent. Let's say these are both were 5. Then we can say this angle here and this angle here are congruent, okay? This one says congruent central angles have congruent arcs. Arcs are the curved one, okay, the curved. So if these two angles are congruent, then this arc here, whatever measurement or number that is, this is equal to that. So if this is 10 here, this is also 10. Or if let's say this was 5x here, and this was 3x plus 10, and these are congruent, so they're equal to each other, we can say 5x is equal to 3x plus 10, right? Because they're congruent. All right, so what can we conclude over here? Here's that problem to the right. It says this circle is congruent to this circle, and BC is congruent to DF. So it's saying this line here is congruent to this line here. Well, if those two segments are congruent, then we can work backwards, and we can say this angle here is congruent to that angle here. So let's say if chords are congruent, then central angles are congruent. Are congruent. Bam. All right, so next part. Congruent chords have congruent arcs. So if this chord and this chord are congruent, then this arc, the curved piece, and this curved piece are going to be congruent. So pause that for a minute, let you guys write that. All right, next one. Chords equidistant, meaning chords that are equal distant from the center, are congruent. So let's say I have this circle right here. If I have this circle right here, chords that are equidistant from the center. So what that means is if we take this chord and this chord, notice how they're the same distance away from my center. Here's my center. Well, they're saying that these two pieces are congruent. So that means this chord and this chord are the same distance away. Tells us this and this are equal. All right, so let's look at this. What is the value of RS? So what is the value of this line right here? Well, if I know that, if I can figure out what this line is and prove that they're the same distance from the circle, from the center, then whatever this line is, this is what that is going to be. All right, so if this piece right here is 12.5, right? So this is 12.5, and this is also 12.5. So from here to here, that's going to be 25, okay? And look, from here to here, that's 9. From here to here, that's also 9. So that means this segment here is congruent to this segment here. So from here to here, that is 25. All right. That was equidistant. Here's the next one right here. This one's kind of a lot to write, so just pause the video real quick, write it down. All right, so it says, if a diameter is perpendicular to a chord, the perpendicular means you have a right angle, then it bisects the chord and the arc. Bisect means to cut in half. So if this right here, if this chord and this chord are perpendicular, then it's going to bisect it. It's going to cut it exactly in half. So if this is 5, this will be 5. And if this is 10 up here, this will be 10 up here. Okay? So what does that mean? If AB is perpendicular to CD, so if AB is perpendicular to CD, what happens? This piece is congruent to that piece, and this piece is congruent to that piece. This arc is congruent to that arc. And then the perpendicular bisector of a chord contains the center. So whatever is bisecting will always have the center on it because it's the diameter. All right, what is the value of x here? So this is kind of like the one we just previously did. Notice how this measurement here, from here to here, that's 36. Well, if this piece is equal to this piece, those are both 36, and that means this piece right here must be equal to this piece right here. So that's 16. All right, so let's do this one right here. What is the value of y to the nearest tenths? Okay, so what do we got? We need to find y, this value right here. For me to find y, what information do we have? Notice how this segment right here and this segment, it bisects it, cuts it right in half, right? Because this piece from here to here is 11. So from here to here is 11. So that means they must be perpendicular. Since these are perpendicular, anytime we have a perpendicular lines, we can make a right triangle. And then here's my right triangle. I'm going to use Pythagorean theorem to solve this, right? What is this measurement, though? That should be 15, right? Because if this is my radius from here to here, that's 15. If I drew a radius here, that should be 15. Right here should be 15. It doesn't matter where I draw as long as it goes to the edge of the circle. It's all 15. So this is 15 right here. All right, since that's 15, I'm looking for my shorter side. We're going to use that formula, right? So it's always the bigger side squared minus the smaller side squared. All right, plug that in the calculator real quick. Bring my calculator out. So we say square root 15 squared minus 11 squared. Press enter. We'll actually erase that. I'm going to approximate this to the tenths place. So 10.2. And then is the radius a chord? We'll say no. Chords extend all the way to the edge of the circle. To edge of circle. Is the diameter a chord? Yes. We'll just say yes. All right, so let me go over your assignment real quick. Over there, these right here. This one says identify the diameter. Look at the chords and identify which one's your diameter. Name a pair of congruent arcs. This right here, find the value of x. So you have to solve for x. Remember which side, what's congruent. So for instance, since this is perpendicular, this is the bisector, which means this piece here is congruent to this piece here. They're equal. Since this chord is equal to this chord, that means this angle and this angle are equal to each other. So you would set it up like x plus 5 is equal to 50 and solve. Since this angle is equal to each other, these chords are equal to each other. And then I think you guys can figure this down here. I'll explain this one right here. Determine whether AB is a diameter. So two things have to apply. So must have perpendicular angles and congruent segments. All right, so you want to make sure that it says determine if AB is a diameter. So you're going to look at one of the problems. We'll look at this actually. So it must have a perpendicular angle, must have perpendicular angles and congruent segments. So you're looking at this. You have congruent segments from here to here. Check. But we need to have perpendicular angles. 85 is not a right angle. So this will be no, not a diameter. And then you'll explain why, because this is not a right angle. So that's how you want to solve that. So that's your